My name is Bartek, and I work as a big data engineer at Agora. And today with Dawid, who's our technical leader, we would like to show you a little bit about what we have done recently in our big data platform. And first thing, Agora, a few words about Agora. It's a media company from Poland, and it runs many different businesses. We have like cinemas, newspapers, radios, and a lot of internet services, and those will be the most interesting for us today. Also, I don't know if some of you are familiar with this page, Quanto Sabes. It's I don't know, we believe it's quite popular.
Don't
here.
ask us why we run a Spanish website, but we do. Yeah.
No, if you don't know it, please visit. And big data in Agora. Well, mainly what we do, we gather traffic data from web pages into our data ocean system. Also, we integrate data from external sources. And as a result of our processes, we provide back automatic recommendations for the web pages, also user profiles. We also try to tag content, and of course, ad hoc analysis are also possible. And in order to meet the ever-growing needs of the business users, we also try to improve our processes, and we will focus mainly on our data capture process here. So this is how it looked like. We gather traffic data from the web pages that goes through our servers that write it down on Kafka cluster. After that, we got this import process that happens once per hour that write it down on HDFS. This process is based on, I believe, a LinkedIn solution called Camus. And also once per day, we use this Camus to clean the data, enrich it with additional stuff, and write it back on HDFS. And this is the data really useful for business users. And this is how it looks like. And our new solution is based on Apache NiFi. So again, from data from the web pages that goes through Kafka, we run it through Apache NiFi that is responsible for cleaning those data, enrich it, and it goes back to Kafka, where it can be moved by Apache Spark process to HDFS. Also can be used by various other processes from this Kafka topic. So this is the extra bonus here. And probably not all of you are familiar with Apache NiFi. So this is kind of a ETL tool to wrangle data around. And as you can see, you have a toolbar with some icons. They are like ready-to-use processors that help you like load data from one source and write it to the other. There are a lot of cool stuff that helps you to build your flow really fast. And this is a sample flow I built once to like, as I mentioned earlier, we also integrate our data from other data sources. And it was like when someone sent us data, we had to wait for this Camus process that happened once per hour to give him a feedback whether this data got past our validations and was properly written down on Kafka. So we could give him that answer after an hour. And this solves this problem like immediately. So you got an immediate response. And there are 5 processors. Basically, what they do, the first one reads data from the Kafka, then we extract and event identification that is in our interest, and prepare and email message that is sent back to the user. And I wanted to show you that it is really not so hard to make such flow in a production environment, and I hope it works. And so I just dropped this first processor that reads from Kafka, then we extract from the content of file the attribute, the event identifier. Some clicking, you have to connect those processors, and another processors checks whether this ID equals the one we are interested in. Okay, so here's the routing property, and the next one will get the whole content from the incoming message to the proper attribute, and the last processor soon will be here.
Yeah, we don't need some of the routes that are that goes from the processor, so they are skipped.
Okay. And this is the last processor that sends the email notification. And now we fire it up. We can see some data coming from the Kafka, and in the background I fired up the event we are interested in, and here goes my mail containing the event that just happened on the one of the web pages. So this took like less than 2 minutes, and it works. And back to our solution that is based on this Apache NiFi project. So we like improve from batching processors to the online one, and we built a lot of custom processors that NiFi allows us to do so. For example, for geolocation, user agent parsing, and then cleaning the data. Also, we put a lot of effort into gathering metrics and to give us an insight into what's happening in real time with whole process and the data that's incoming to us. So obviously, as we see it, one of the biggest advantages of NiFi is the graphical user interface that really helps you to quickly develop new flow. Got a lot of ready-to-use components to, for example, read from Kafka, write to Hive or to HBase, Cassandra, and all this ecosystem, not only in SQL databases, but also to like Postgres, MySQL, so on. And we believe there were a lot of problems that we avoided using NiFi, for example, like back pressure or fault tolerance. We didn't have to worry about it, and of course some errors could be handled better. It's not like ideal tool. Sometimes something crashes and it's hard to get to the source, and well, the DevOps support could also be a little bit better. For example, when we develop new things on the test environment and we want to move it to the production one, well, we had to write our own deployer for that, and a few problems with Kerberos happens.
All right, so we'll move on to some fun stuff, because as Bartek showed you, pointing, clicking, dragging some processors on a graphical user interface is fun, but then you have to put it on production. And there are some challenges that we faced, and we think we've managed them in some way. And we want to share with you our lessons learned. Right. The whole application of Apache NiFi is built around so-called flow files. So the pieces of information that are flowing through the pipeline. And the flow file consists of content and some attributes. In our scenario, we wanted to gain some performance using micro-batching, so stuffing a lot of pieces of content in one flow file. This led us to the this evolution of flow file content that we were using. So basically, we could have everything in JSON. In JSON in a content and use some attributes. But attributes are only like is one instance of them per flow file. So we couldn't use them using our micro-batching approach. So yeah. So we just put our pieces of data all together to the content of flow file. As you can see, we split the data between raw data, so the one which go into the flow, and the so-called parsed data, so the data that are added during the flow. And so as you can see on the right, there are many of those in one flow file. Another consideration is the format you use during the flow. So in a standard approach, you have some, for example, JSON. You feed the first processor with the JSON. It's doing some business logic on it. So it has to deserialize the JSON, do something, serialize it, put it on a queue for another processor, and so on. And this leads to significant overhead during the serialization process. So we are doing our serialization and deserialization to JSON object just once. One on the deserialization on the first incoming edge to the process, and serialization at the end. And throughout the process, we are using Java objects that are serialized using protobuf serializers. All right, and building the process of data enrichment, you have to deal with some settings of the Apache NiFi processors. One of them is throughput versus latency. So while the processor is operating, it has to process some flow files and then update the content repository. So the place where the content of flow files is stored. And whether it should do it more often, gaining on the latency, or more rare, gaining on the throughput, is up to your application. In our case, we basically do it, set it on a high throughput, and it performs well. You cannot. You have to remember that the Apache NiFi is a Java application, so optimizing on garbage collector can get you a significant boost in performance. And this is the state before our optimizations. As you can see, or not, but the chart shows that over 80% of the time application was garbage collecting. And those green dots are bad because there are full pause for the garbage collector. And after some tweaks, we switched the situation. So using, for example, G1 garbage collector and some other tweaks on JVM lead us to the 80% of application running and only 20% of garbage collecting. That was nice. And then there is the need of deciding whether you would like the content of the flow files that are flowing through your process to be stored on disk or in memory. As you know, writing anything to memory is it can lead to data losses in case of crash, of the machine crash, but it's faster. And as we considered the I/O overhead to be unmanageable, we thought that the so-called volatile content repository would be suited for our case, and we joined it with come on. Oh, yeah. We joined it with small queue sizes, so the queues that are those places where flow files are waiting to be processed by another processor. So small queues and volatile content repository gave us the advantage of low resource needs, so low RAM needs, and minimizing the potential data loss when, for example, one of the machine processing the flow would crash. Yeah, as you can see here, there are two sample processors connected with this arrow that depicts a queue. And when the queue is full, for example, the automatic backpropagation process is triggered. Yeah, so adjusting the queue size seems to be quite important. Right, and as Bartek said, we put a lot of effort to have monitoring process at high detail level. So we are monitoring every part of the process, having information about the processing time, some delays, errors that are due to some bad, ill-formatted data or whatever. As you can see, Quantos Abbes is somewhere here in our services that we are monitoring. And building the process, we also, do you see anything here? We also tried what happens if we, for example, have a one-day outage and our server is down for 24 hours. And as you see, this is a chart for the delay of data. So the time of data that are waiting for being fetched from Kafka by the first processor in our flow. So it grows linearly for 24 hours, and then we managed to process all the data in 2 hours with our flow. So I think that's pretty impressive. Yeah, and at the end of the process, there is the data ingestion. The data ingestion was really great fun for us because we took several approaches to build the process of fetching the data with Spark structured streaming from Kafka, and put it on HDFS to Hive database. And what we learned from that is that Apache structured streaming is not just quite as stable as we would like. Maybe I will start from the beginning. So the structured streaming can easily fetch data from Kafka and put it on HDFS. The problem is that we wanted to have it in Hive table. So we should update the Hive meta store for that, and this was the tricky part. So we took several approaches. First one was to have custom script. The first version was using the MSCK repair table, although our our version of Hive was too low to manage like batched updates on partitions, so it failed. Then we tried to write our custom sinks for structured streaming, and the first approach was to use the API of Spark, having a data frame insert into a Hive table. It was okay, but it was run on single executor, so it was very prone to failure. And then we were digging in the code base of Spark, and we find out that there is a function that can be used to firstly put the data into HDFS and then call a callback on every partition that was modified by this writer. Although in standard distribution, this function is not used, so the callback there is just unit function. So we took some pieces of code, made a custom sink that was updating the partitions, and it all was the whole process was running quite good. But then we stumbled upon some bug in Spark. It's essentially here at the top. So failed to read log file, incomplete log file. So what happened was what was happening. Spark was writing logs in its directory, but some logs were empty, and Spark couldn't deal with empty log files, and it failed to move on. So we couldn't come up with a solution on that. So we tried another approach, the one at the bottom. Essentially, we are using the good old Spark streaming without the structured part, and Kafka direct APIs. Our colleague Arek was talking about it a few sessions ago. So basically, we are fetching data from Kafka of defined offsets. And then we are writing to our zookeeper the offsets that we fetched. And then after processing those data of those offsets, we are writing the processed offsets. Those double accounting, so these two numbers allows us to deal with crashes, for example, or not or incomplete batches, so that we know what was fetched from Kafka and what was processed. And that was one of the biggest challenges we faced. And that seems to be all. Muchas gracias. Yeah. If you have any questions, I think we have 3 minutes. Or our. Okay. So if you want, you can approach us after the session, and we hope you liked it. And yeah, thank you.
Thank you.